Today's lesson, section 2.3, will be getting information from the graph of a function. So, when we're looking at a graph of a function from left to right, the graph can be increasing or decreasing. So, if f is increasing on an interval I, that means your y values, one is going to be smaller than the other, so f of x sub 1 is going to be less than f of x sub 2 whenever x sub 1 is less than x sub 2. So as I move from left to right, and looking at this graph, here's my origin, okay? And so this number is obviously smaller than this number based on our location on the x-axis. And so looking at our graph, this function's value is going to be smaller than this function's value. So that means we're increasing on that part of the graph. So it would be an increasing interval. F is decreasing on an interval I if f of x sub 1 is greater than f of x sub 2 whenever x sub 1 is less than x sub 2. So looking at my graph, still this is our origin. Okay, so this x value is smaller than this x value. So that means for this graph, f of x sub 1 is bigger than f of x sub 2. So the y values are different. So we're oriented differently so that it creates a decreasing interval of our graph. So here, we want to be able to sketch the graph, and I've already sketched it using my graphing calculator for the function f of x is equal to x cubed minus 6x squared plus 10. Here I want to be able to state the intervals of increasing and decreasing portions. So here, as I move from left to right, so that means I'm coming from negative infinity, okay? And I continue to move this way until I hit a spot where I stop increasing. So that would be the point 0, 10. So an increasing interval would be negative infinity to 0. Now how I write this interval is just like what we learned with interval notation. Infinities are always parentheses because we're never going to meet them. So that's why I have a parenthesis next to the negative infinity. I have a 0 or a parenthesis next to the 0 because if we use some calculus terms here, if I took the derivative of this function at the point 0, 10, the derivative actually tells me the slope at which or at any given point in my function. So at the point 0, 10, the derivative is actually 0 at that point. So it's telling me that the slope of my graph is 0. So since it's 0, that means it's neither decreasing or increasing, and so therefore I can't include that point in my increasing interval. So I need to put a parenthesis in there so I don't include it. For my decreasing, now as I move from 0, 10, I continue moving this way. I head to 4, negative 22, and I stop decreasing. So for the same reason, I put a parenthesis next to my 0, and then also a parenthesis at 4, because I'm not decreasing or increasing at that point because my slope is 0, because it's like the bottom, the middle, or the minimum. Okay? Then I continue to increase as I head towards infinity from 4, so then I would say 4, infinity, parenthesis. And so those would be my answers, or my intervals, for this given function. So notice that the spots where they stop increasing and decreasing are where the mins and maxes happen for your function. So those are critical points that we want to find for all our functions for this. The next part is talking about when your function is positive and negative. So f is positive on an interval I if f of x is greater than 0. F is negative on an interval I if f of x is less than 0. So here I have sketched the graph as well using my graphing calculator, and I have located, more importantly for this one, is where my zeros or my x-intercepts are. Okay, so to find positive and negative intervals, I just need to look at from left to right when I'm below the x-axis and when I'm above. So for a positive and negative, looking at from left to right, I'm starting from negative infinity and moving towards, it looks like negative 2. There, because you're at the x-axis, your y value is 0. So for the same reason for where we put as a parenthesis for our increasing and decreasing stuff, we would also put a parenthesis for our negative and positive ones. So they're always going to be parentheses for all our stuff in our increasing and decreasing intervals and our positive and negative intervals. So here I would have a negative interval of negative infinity to negative 2. Now notice it's not because the numbers on the x-axis are negative, it's because your function is below the x-axis. So then as I move past that, it looks like it goes above at negative 2, so we start to be positive, and it heads all the way down to back to 1. And then it becomes 0 again. So then it goes from positive to 0, which is not positive anymore, and then we continue. You go to 1, 2, 3. So therefore there's an interval where it's negative right here. Okay? And then it ceases to be negative anymore when it hits the 3 x-intercept, and then it continues to go up from 3 to infinity as we move left to right. So there are my intervals of positive and negative values for this function. Now the next thing we want to be able to talk about is local maxes and local mins. Now for the increasing and decreasing intervals, it was important to find those, so we need to be able to find those for any given graph. So local max is a maximum value of the function f of x in a given interval. Local minimum is a minimum value of a function f of x in a given interval. So these are not the overall maxes and mins, because if you look at all these functions, look at where they're heading. So looking for the mins and maxes would be super easy because they're always going to be either negative infinity or positive infinity, unless there's like the arrows go in the same direction, so then it creates one single max or one single minimum. So we want to be able to look at local minimums and local maximums because they're a little bit more interesting, plus they're pertinent to being able to graph our functions. So in this function, look at the green circles that I've made. Those are going to be a local min and local max, because in a given interval, it's a high point or a low point in our function that is kind of important. Okay? And so before, in the last picture, we had a local max of 0, 10 and a local min of 4, negative 22. So those points were important to be able to find our intervals, so we want to be able to find those as well. So now in class, because this is a calculator value or task, I can't really show you on this video to be able to actually give it justice so that you understand what's going on. So we're going to state the local min and maximums of the previous examples, and so you kind of already have the local mins and maxes of the example 1, so we'll really kind of mainly look at the other ones just so you're aware. But I'm going to show you how to find those in class, so just write this example down and then I'll give you some kind of pointers on how to find that using your calculator. If you already know how to use it on a calculator, you're good to go, but most people don't know how to use the graphing calculator to find this. Okay, so we'll talk about that in class tomorrow. Okay, have fun. Bye.